Hi everyone. The goal of this video is to dive deeper into arithmetic sequences. I know it looks like arithmetic, but it's pronounced arithmetic when we're talking about sequences. So by the end of this video, you should be able to define how to find a general term, which really means write a formula for an arithmetic sequence. And you should also be able to define a specific term for the arithmetic sequence. We're going to look at common differences and first terms and stuff as well. Anywho, I hope you answered this before watching the video. If not, you should pause now. But I asked, which of the following sequences is arithmetic? The answer to that question is number 2, because in order to get from one term to the next, you have to add 4 each time. This is the only one with like a constant difference, which makes it linear. This one you just don't have enough information to tell, because the next number could be 20, and then there wouldn't be a common difference. Okay. So definition of an arithmetic sequence is it's a sequence with a common difference. Or another way to put it is arithmetic sequence is a sequence of numbers where the difference between two numbers is constant. I'm going to abbreviate between. That's between two numbers is constant. Just an important vocab word that kind of comes straight from the definition is common difference. Okay, common difference is that number that is constant. So I know I'm being redundant, but I want you to have these written down. The common difference is really defined as the difference. I'm using a word in the definition that's from the word, but whatever, you live. That's the difference between each number in the sequence. Or I should say in an arithmetic sequence, but I'm trying to abbreviate this and get this going. So an example from our arithmetic sequence up here, the common difference would be 4. Okay? Now, the formula for an arithmetic sequence we've kind of already talked about. We know that arithmetic sequence is very, very, very closely related to a linear function, except we're not talking about functions, we're talking about sequences. So we kind of compared an arithmetic sequence to an equals like mn plus b, like mx plus b, right? So that we've already talked about. There's a more concrete formula that I want you to be aware of, and also I want to derive for you because this formula may be more useful in certain problems that I give you, which you'll see later. So another formula for an arithmetic sequence is the formula an equals the first term, which we call a1, plus n minus 1 times d, where d is the common difference. Okay, so this formula is nice because if I know the first term and I know the common difference, I can compute any other term without writing it as a linear model. So again, d is the common difference. Now let's talk about an example where you might want to use this formula. So say I give you a problem that says an arithmetic sequence has a1 equal to 17. So just notation reminder, a1 means the first term, because that 1 tells you the position. D is 4, so again, D is a common difference. It asks you to write an explicit formula and then go ahead and find the 25th term. Okay, so why might I want to use this formula instead of the other? And again, you could use either one and you'll get the same thing, but sometimes one's more efficient than the other. So if I know the formula is an equals a1 plus n minus 1 times d, then I can go ahead and just plug in what I know. So a1 is 17. I don't know n yet, just because I'm writing an explicit formula. And our common difference is 4. Now, if you go ahead and multiply this out, you would get the mx plus b format anyways. So it'd be like 4n minus 4, I have that plus 17. So you're going to get 4n plus 13, which if you actually went through the process and found the formula similar to how we did in class, this is what you'd get. Now the only problem with this is I only knew one term. So I knew the common difference was 4, so it'd be 4n, but I didn't know how it was going to shift. So in this particular example, with the information you're given, you have to kind of use this formula. But from that formula, if you want, you can get this, but you don't have to. Like I could have just left it right here, and that would be totally fine. I just wanted to show you that it is equivalent to what we did. It's just another way of using it, and it's more useful in certain situations than others. So with that said, this is the explicit formula. It's totally cool to leave it this way. And I can use this explicit formula to find A25. So again, I just plug in N is 25, 17 plus, boom, 25 minus 1 times 4. And I can find A25. So that's, let's see, 24 times 4. You should be computing this on your own. All of that combined will give you 117. And that's your 25th term. Okay, so I don't love this formula because, yeah, you kind of have to memorize it, whereas like linear you're very comfortable with, but it is more useful in certain situations. Now, although I'm saying like you kind of need to memorize this, we need to understand where it comes from. So let's go backtrack. Now that you know why you need to know this formula, let's figure out where it comes from. And I already have this table written out to kind of explain it. You may want to write this down or take a picture of it, or you can just write down what you need to, that's fine. So we're going to go and compare it to the arithmetic sequence we looked at in the first step, 3, 7, 11, 15, 19. Okay, so this is the sequence. Let me explain what this chart does. So first term, second term, third term, fourth term, fifth term, right? So our first term is 3. Our second term is 3 plus 4. Our third term is 3 plus 8, right? Maybe I should write what those are. So 3 plus 4 is 7, 3 plus 8 is 11, right? It's the same term, the same sequence as we were looking at before. Okay, so it's 3, 7, 11, 15, 19, you're adding 4 each time. Okay, now let's look at this next column and this next column because this will kind of explain where this formula comes from. Okay, so I start with 3. To get to the first term, like I don't want to add any 4 because that's where I'm starting with, so I'm going to add 0 4s. Okay, but to get to the second term, I only add 1 4. Right, to go from here to here, I just add 1 4. To get to third term, I have to add 2 4s. You know, 8 is 2 4s. I've added 4 twice, which means to get from 3 to 11, I have to add not 1 4, but 2 4s, because I added 4 here, then I added 4 again, so I'm adding 2 4s. That's what this says. To get the fourth term, I had to wind up adding 3 4s, which is 12. So I added 4 3 times. That's what this says. The next one, I added 4 4 times, right? To get from 3 to 19, I had to add 1, 2, 3, 4 4s. That's what this column is describing. Okay, now the last column is kind of formalizing how this idea connects to this formula. So bear with me. In order to add no 4s, I needed a 0. But we define n as the, the position of the term. So, if I plugged in 3 plus 4n, right, that wouldn't work because n was 1, so I'd actually have to be 1 4. So to add 0 4s, n would need to be 0. In order to make n 0, well, I can't just change this number, I need to make it n minus 1. So it really needs to be 3 plus 4 times n minus 1, because then if I plug in 1 to that formula, I'll have 1 minus 1, which is 0, so I'd be adding 0 4s. Same thing here, I only had 1 4, but it was a second term. So to add 1 4, I have to do term 2 minus 1 to get only 1 4 added. So that's where this comes from. And that's just the n minus 1 piece that I've explained here, right? So we're comparing, this equation to this one wouldn't work, this one does. Okay, let's analyze the rest of this equation then. This 4, why does that 4 appear there? Well, first of all, the 4 is a common difference, right? So I got the n minus 1 part, that would be here. Okay, now I multiply n minus 1 by the common difference. Oops, that should be a highlighter. Which you see works in this equation, right? Like I multiplied n minus 1 by our common difference was 4. The reason is because it's essentially the slope. It's, you're adding 4 a repeated amount of times. It means you're multiplying 4, which means you're multiplying the common difference. That's very similar to what we talked about in class. Okay, now you're going to always add on to that the A1, which is the first term, which you see here. Our first term was 3. The reason that is because this is where it starts, and you're growing from there. So I start at 3. That's what that describes. That's constant. I'm always going to start at 3 for the sequence. And this describes what you need to add to the 3 to change from this term to this term, or from this term to this term, this term to this term. So that's why this formula makes sense. You can also compare it to a linear function, and it works nicely that way. Up to you. Okay, what I want you to do now is to try 3 and 4 on your own. They're all slightly a little bit different, but they all kind of practice this formula. Please come with questions if any of that was confusing.